Okay, we're going to look at two problems now that sort of pull a lot of stuff that we've done in probability together. See if we can do these. So this test is used to determine whether HIV antibody is present. The test is 99.5% effective, which means that the test will come back negative if the HIV antibody is not present 99.5% of the time. So the probability of a test coming back positive when the antibody is not present, a false positive, is 0.005. So suppose that the ELISA is given to 5 randomly selected people who do not have the HIV antibody. They don't have it. What is the probability that the ELISA comes back negative for all 5 people? So think about this. We want 2, 3, 4, 5. We want this one to come back negative, and all of them to come back negative for all 5 people. So what's the probability that it'll do this? So if it's not present, the probability is 0.995. So 0.995 for this guy and for the other people. And then I multiply those together because we want this one to come back and this one and this one and this one and this one and this one. So I can get my calculator out. So this is 0.995 raised to the 5th power. 0.9752. Okay. What is the probability that the test comes back positive for at least one person? So remember, at least one, you can kick in your head that it comes back negative. It's 1 minus the probability that it comes back. Remember, it's 1 minus the opposite of this, so it comes back negative on everybody. So we just found that out, right? So it's 1 minus 0.9752, which is 0.024. Let me do that. I don't want to mess that up. 1 minus that answer there. 0.024. Yeah, I wasn't sure how much I should round here, so let's say 8. These are not terribly easy problems. You got to think about these. Okay, because in the real world, you're not going to most likely be dealing with dice and cards unless you are going gambling or something. According to the Health Department of Health and Human Services, 30% of 18 to 25-year-olds have some form of mental illness. What is the probability that 2 randomly selected 18 to 25-year-olds have some form of mental illness? So again, pause the video here, see if you can do A through D here. All right, welcome back. So we want this person to have mental illness and this one. Let's put an M for mental illness. So the probability this one gets it is 0.3, and assuming independence, these are not related people, brothers, sisters, husband, husband, wife. Multiply those together, you'll get 0.09. So what is the probability that 6 randomly selected 18 to 25-year-olds have some form of mental illness? So very similar, right? This is going to be 0.3 to the 6th power. Cannot do that one in my head, so let's do 0.3 to the 6th. Okay, so this is 7.29 times 10 to the negative 4. So we never really write it that way, 7.29 e negative 4. So let's write this as 0.000729. So just remember scientific notation. This is 7.29 times 10 to the negative 4. And we just shift the decimal point over 4 places to the left when it's negative. Okay, part C. What is the probability that at least one of the 6 randomly selected 18 to 25-year-olds has some form of mental illness? Okay, it's a little tricky. So remember, when you see that at least one of 6, so what we want to do, we have 1, 2, 3, 4, 5, 6. We basically want to find the 1 minus the probability of none, right? Of no mental illness. I probably should say no mental illness here. Okay, so no mental illness there. So what's the probability that this first person here has no mental illness? 30% do have one, so how many don't have one? 70%. Same for this one, we're assuming independence. And we're going to do 1 minus that. So this is 1 minus 0.7 to the 6th, right? So 1 minus 0.7 to the 6th. One minus 0.7 to the 6th. 0.8824. About 88%. So would it be unusual, part D, that among 4 randomly selected 18 to 25-year-olds, that none has some form of mental illness? Remember our threshold for unusual is it less than 0.05. Okay, so we need to find out the probability that 4 people, we have 1, 2, 3, 4, that this person does not have a mental illness, that this person does not, this person does not, and this person does not. So the probability that each one of them do is 0.3. So the probability this one does not is 0.7. And so 0.7 raised to the 4th. 0.2401. So is it unusual? No, that is not less than 0.05% or 0.05%.